Hello, we are UCLSwift. Now we'll start to have a look into the Swift solution for FTTH, which is going to be focusing on the fusion splice on connectors for the last mile connectivity. Table of contents, we're gonna start with market trends, what has been happening and today. Just brief concept of fiber to the home. Different types of dropped cable termination methods. And what is the best option you are going to choose? Field installable connector technologies. Mechanical splice on connector. And fusion splice on connector. Summary and finally case study, couples of examples of FTTH installation in the world. Since fiber cables have virtually unlimited capacity, the number of internet-connected devices today is over 17 billion. That is more than twice the global population. IBM expects data to grow by another 800% over the next 5 years. FTTH has been a key technology compared to other technologies such as cable, copper, satellite and wireless. Total global broadband subscribers reached 1 billion as of first quarter of 2019. FTTX and FTTH market is still growing, and copper connections continued to decline, having dropped by 9% in 2018, while FTTX connections increased by 24% in the same period. The trend of subscribers with fiber to the home or building continues to increase. China continued to be the largest fiber growth market. In 12 months to the end of first quarter of 2019, China saw FTTH connection grow by 23%. Some 72% of global FTTH net adds in first quarter of 2019 came from China. Argentina, Thailand, Philippines, Chile and South Africa among others also saw significant FTTH quarterly growth rates 53%, 34%, 26%, 20% and 17% respectively. Why fiber to the home? Fiber to the home refers to the use of fiber optic cable to deliver broadband internet connections from a central location directly to the home. With FTTH, customers get faster internet and increased bandwidth. They can stream higher quality content and have more devices connected to the internet simultaneously. In addition, users can get internet and TV service over the same broadband connection. FTTH is an attractive solution for network builders as the core fiber technology is future-proof, meaning it will be able to support broadband demands for the foreseeable future. A passive optical network (PON) is a point-to-multipoint FTTH network architecture in which unpowered optical splitters are used to enable a single optical fiber to serve up to 128 customers. A PON reduces the fiber and central office equipment required compared with point-to-point architecture. The downstream signal coming from the central office is broadcast to each customer premises sharing a fiber. Upstream signals are combined using a multiple access protocol, usually time division multiple access (TDMA). We can say that FTTH is all about cabling such as feeder cabling, distribution cabling and dropped cabling from central office to home, and sending light from OLT through the fiber and distributing it with the optical PLC splitter, and finally receiving it from ONT terminated with field installable connectors. There is two equipment for passive optical network, such as optical line terminal, OLT, in the central office, and optical network terminal, ONT, at the point where the fiber terminates. As you can see in the diagram, CAPEX capital expenditure is the biggest portion, 67%, which is fixed expenditure related to fiber deployment, fiber trenching, equipment deployment for outside plant. Service provisioning includes optical splitters, fiber, distribution boxes, and connector splitter failure will increase this part of the expenditure. Operational expenditure includes maintenance of ONT, ISP, and OSP, so maintenance occasions mostly from connector and splitter. We can conclude that service provisioning and OPEX could have cost reduction by choosing proper and reliable products, such as fusion splice on connectors and good quality of optical splitter. From the previous slide, we have learned the poor quality of the optical splitter and connector would increase the deployment cost. And we are going to have a look into the weakest point in the FTTH network, which should be near home, such as dropped cable termination from pole to ONT inside the home. Feeder cabling causes seldom trouble, however, the optical splitter can be damaged easily if the poor quality of splitter is deployed in the distribution point, and we have witnessed the connector failure frequently and mostly by adopting the fast connector called the mechanical splice-on connector. In the end, the poor quality of connectivity will increase the cost of service provisioning and operational expenditure. Also, once again, what should be the biggest cause of FTTH network failure? As you can see from the drawing on the right, connector is the biggest portion of the failure, 54%, and followed by the splitter, 16%. The network failure causing from the connector and splitter will increase the cost. Then how are we going to avoid this and reduce the cost? First, the proper and reliable field installable connector, such as the Fusion splice-on connector, should be adopted at the subscriber's ends. And secondly, the good quality of optical splitter should be used in the distribution boxes. Termination methods and what to choose. Splice-on connectivity has been heavily adopted in the FTTH network. The more fiber to the home, fiber to the building subscribers increase, the more service providers require connectivity from drop cable to indoor cable. FTTH connectivity is costly and critical, so that it should have reliable, fast, and easy solutions out in the field, and the cost reduction should be considered with high quality. The pre-terminated drop cable is one of the fascinated connectivities, however, this technology cannot save material cost, which should be increasing because of excessive slack, about an average of 30 meters. So field installable technology should be considered for FTTH connectivity from the pole to ONT inside the home. There are two types of field installable connectivities, such as Fusion splice-on connectors and mechanical splice-on connectors, and we should compare two connectors and find out what is the best option for the fiber to the home network. The drop cable connectivities are shown here, one with the drop cable terminated by Fusion splice-on connectors and the other with mechanical splice-on connectors. Normally, the distance from the pole to home is around 100 meters. Requirements for the field installable connectors. Obviously, quality is a top priority. After splicing, both mechanical and fusion, the optical performance should be verified whether it is good or not. The insertion loss and return loss should be critical factors, and these could affect on-site repair, replacement, and future maintenance. Installation should be easy with a few trials and short lengths of training, and also installation time is considered enough for widespreading adoption of the fiber to the home. Fast installation keeps the labor cost down. Field repair could be quick, clean, and safe with the best performance and reliability. Finally, cost. The cost benefit should be considered for the fiber to the home connectivity, and this connectivity is not giving up any performance based on the lower cost, which becomes the primary requirement along with fast installation. This should be able to keep the labor cost down. We can compare both connectors and choose the best one for the fiber to the home network from this page. As you can see from the comparison chart, you can have a look at the advantages and disadvantages. Features of mechanical splice-on connectors are easy assembly process, and fiber can be reseated, no expensive tools required, no epoxy required, factory polishing eliminates loss concerns, and this connector meets TIAEI of 568A performance requirements. However, a mechanical toolkit is required. Low return loss. Gap fiber to fiber, 40-50 dB unconformity in analog network, greater than 55 dB. High insertion loss and high failure. Splicing loss, no predictability, only visual fault locator check. Weak on vibration. Splicing. Skilled person oriented. Low reliability. Buckling, fiber to fiber gap, index matching gel. Signal interference, noise issues. Now, the advantages of Fusion splice-on connectors are superior optical, mechanical, and environmental performance. Splicing point and its protective tube located inside the connector. No cable slack required. Strong tensile, 4.5 to 6.8 kg force, enables outdoor deployment. Improvement of quality and reliability reduces maintenance cost and labor cost dramatically. Reduction of installation cost. Compliant with Telcordia GR326 core. However, a Fusion splicing machine is required. As you can see in the table, the performance, strength, materials, tooling cost, and installation time of both connectors are similar, but the maintenance cost for the Fusion splice-on connector is much lower than that of the mechanical splice-on connector. This is the biggest factor to be considered for FTTH deployment. Field installable mechanical splice-on connectivity is based on mechanical splice technology, in which two cleaved fiber tips are mechanically contacted and aligned to each other by a special housing, for example, V-groove and capillary, as shown in figure. And the index matching gel is located between the fibers to decrease the reflected energy of light. It requires a tool kit for assembly, and it is known as a fast connector. However, its failure rate is very high, which may cause a cost increase in the initial deployment and future maintenance. So adoption of this type of connector could be problematic and a disaster for FTTH networks due to frequent situations for maintenance and repair. Estimated connector loss for mechanical SoC is about 0.5 dB, which includes connector loss and mechanical splice loss. The pre-cleaved fiber end in the stub is the most important factor to minimize attenuation. For example, the angle of the pre-cleaved fiber is a critical attribute to determine the quality of the connectivity. The cleaved fiber angle in the figure, C, on the left, will cause poor quality. Also, you can find incorrectly cleaved fiber ends from field fiber on the right. This will cause a connector failure at the subscriber's end. Mechanical SoC is sensitive to many factors. There are a large number of factors to cause failures. And most of the factors are located at the end of the end face of the fiber. Contamination embedded in the index matching gel, glass fragments in the index matching gel, incorrect fiber length, and joining cause excessive fiber gap, poor quality of cleave or bad cleave will cause higher attenuation. Since index matching gel is a critical material, we should know what will happen without index matching gel. If insertion loss of the perpendicular cleaved fibers without gel could be okay, but return loss should be about 14 dB, which is extremely low, and this will make light travel back to the light source and cause damage to OLT equipment, and sometimes index matching gel may be dried up in the connector. From the previous slides, we have learned the index matching gel is a critical factor for the mechanical SoC. As seen in the figure on the right, the blue line is the index of refraction for glass fiber, and the red one is the refractive index for gel. So the index matching gel is engineered to produce an optimum index match with optical fibers at room temperature. But the gel's refractive index changes with temperature differently than that of glass. This will cause return loss degradation and make network failure in the future. As seen in the figure, return loss has decreased by 10% from its room temperature value. Temperatures down to -30 degrees Celsius below or rises above +50 degrees Celsius decrease to less than 40 dB return loss. This will cause network malfunction temporarily under the extreme temperature of the outside plant and make the mechanical connector less reliable. Fiber scratching by a manual stripper will cause fiber breakage inside the connector, and 35% of faults and failure from the fiber scratching from NTT report. If the first installation of mechanical SoC is not satisfied with the performance, the mechanical connector can be reused for good. But reuse can degrade the return loss. Even if the insertion loss is similar each time on the right figure, the return loss is decreased by multiple reuses of mechanical SoC, dropping from 47 dB to 40 dB. So it is not recommended to reuse the mechanical SoC. Despite the good features of mechanical SoC, it has had the critical drawback of a 30 to 40% connection failure rate. This will cause the FTTH network malfunction severely and installation costs to increase. The case studies from some countries' FTTH will explain to you the failure rate mentioned. So we are introducing Swift Fusion Splice-on connector with all-in-one fusion splicing machine, KF4A. As the number of problems in the FTTH network is mostly coming from the connectivity and drop cabling, the fusion splice-on connectors can be the most reliable solution and reduce the maintenance cost dramatically. High-quality, low-cost fusion splice-on connector, FSOC, has become the most reliable solution to terminate the fiber out in the field for FTTH outside the plant. The FTTH Fusion SoC has a factory pre-polished ferrule, and it requires no epoxy or no field polishing. And the FTTH Fusion SoC utilizes Swift series of the Fusion splicers, such as KF4 to terminate connector, and it is compliant with Telcordia GR326 core. The features of Fusion Splice on connector is cleaved fiber ends and angles are checked with Fusion Splicer, and the result can be seen in the display. Fusion splicing typical loss is 0.02 dB and max 0.05 dB. Connector end face typical loss is 0.1 dB and max 0.2 dB. Therefore, Fusion Splice on connector loss can be less than 0.3 dB, and return loss of Fusion Splice on connector is greater than 55 dB for UPC and 65 dB for APC. And Fusion Splice on connector has great mechanical performance, such as 4.5 kg force, straight pull at 0 degree of the proof test, 1.7 kg force, side pull at 90 degree of proof test. As you can see the basic structure of Fusion Splice on connector, the Fusion spliced point is protected with heat shrinkable tube, and end face of connector ferrule is pre-polished at the factory to enhance optical performance, and boot and screw cap can clamp the drop cable tightly for the better mechanical performance. The KF4 Fusion Splicer is the best performing and most effective tool for terminating optical cables in the FTTH network, and the field installable Fusion Splice on connector and Hardened Fusion Splice on connector can be assembled on site in the FTTH last mile, and various types of cables such as 0.9 mm, 2 mm, 3 mm, 2x3 mm drop cables and ruggedized drop cables can be terminated with those Fusion Splice on connectors. With a compact, light, rugged design and a long-life battery, the KF4 delivers high-precision performance with electrode life up to 38,000 splices and provides rotating blade life up to 75,000 fibers. The all-in-one function of the KF4 splicer is patented by UCLSwift. This provides the best workability and convenience on poles or in limited spaces by integrating stripping, cleaning, cleaving, splicing, and sleeving functions into one splicer. The thermal stripper in the all-in-one system prevents scratches or crack on fiber that is usually caused by manual strippers. Installation time for connectors only can be about 5 minutes for both mechanical and Fusion Splice on connectors. But when it comes to concerning installation time, drop cabling from pole to home takes more than 1 hour depending on the distance, complexity of cabling, and the structure of houses. Inside home cabling also takes time as well. So installation time should include drop cabling, inside home cabling and connector assembly time. Depending on the situation of telcos, couples of houses can be subscribed as shown for examples. As you can see in the graph of the environmental performance, the Fusion Splice on connector has performed greatly in the temperature chamber from -40 degrees Celsius to 75 degrees Celsius. And UCLSwift has a hardened type of Fusion Splice on connector as well. Hardened drop cables and connectors are environmentally robust to provide a reliable interface in the outside plant environment. UCLSwift has developed a field installable hardened Fusion Splice on connector, which can be cost savings for wasted cable slack, perfect quality with fusion termination, and it provides neatly organized cables on the pole. Applicable cables are 5.8 mm drop cable, 5 mm drop cable, 5.4 by 3 mm ROC drop cable, 8.1 by 4.5 mm SST drop cable. The basic structure of the Hardened Fusion Splice on connector is shown, and we now have KF4 AHDC for installing the Hardened Fusion Splice on connector. We can find a comparison of installation scenes between pre-terminated drop cable and Hardened Fusion Splice on connectors. No cable slack is required as shown in the photos. You can see the exploded view of the Hardened Fusion Splice on connector and its optical performance. Insertion loss is typically less than 0.15 dB and a maximum less than 0.3 dB, and return loss is greater than 60 dB for APC. Environmental performance and mechanical performance can be found in the tables. Now we will show and compare couples of case studies of FTTH projects in the world. Some cases from FTTH trial services and some are from real FTTH installations. Korea Telecom in Korea has deployed mechanical SOCs since 2007, having a 15 to 25% failure rate from the initial installation. Another 25% failure would occur within 2 years, and this would cause unexpected maintenance costs, and 25,000 labor forces for the faulty connector maintenance could be required. China Telecom in China had installed the mechanical splice-on connector in 2011, and rapid FTTH deployment was driven by the government. However, the failure rate was over 50% for a city. Next slide, and some other cities had similar failure rates as well. So China Telecom has adopted fusion splice-on connectors and other alternative connectivities instead of faulty mechanical splice-on connectors. The failure rate for this table is from the paper of IWCS Conference 2012 and has seen the biggest portion of the failure is from the termination failure at the subscriber's end, which is 50.4%, and the mechanical SOC malfunction rate was about 54%. Since China Telecom experienced the termination failure from the connectivity, mechanical splice-on connectors are not preferable for installing the connectivity at the subscriber's ends. Since Telkom Indonesia in Indonesia also has experienced a big failure from the mechanical splice-on connector, Telkom Indonesia has heavily adopted fusion splice-on connectivity from 2013, and still, they are installing fusion splice-on connector along with the pre-connectorized drop cable. Since we have had FTTH trial service for PLDT in Philippines, the optical performance has been superior less than 0.2 dB. The distance between the pole to home was about 80 meters, and 4 fusion splice-on connectors have been installed as seen in the figure. Another example of installation for PLDT in Philippines at this slide, and 6 fusion splice-on connectors have been installed having less than 0.2 dB average as seen on the figure and photos. True Telecom in Thailand, since they have suffered a huge faulty rate of 40–50%, they were looking for alternative connectivities, so UCLSwift has proposed a field trial service and the faulty connectors removed and replaced with fusion splice-on connectors, with the best results as seen on this slide. Initial power has improved from 24 dBm to 16.9 dBm in the end. Another example of installation for the field trial service for this slide, and the loss has improved from 27 dBm to 14 dBm, with replacing the connectors only. Idea Telecom in India also had a similar failure rate of 40 to 50% from the initial installation, and after replacing the connectors, the result was improved, and the performance has been proven out in the field. After a couple of proposals and field trials for Reliance Jio in India, the quality and reliability have been proven, and now Reliance Jio is installing the fusion splice-on connectors at the subscribers' ends. In conclusion, since most of the telecom companies would like to adopt good quality of FTTH connectivities and solutions, and UCLSwift creates specialized designs and researches and develops FTTH total solution products such as fiber optic fusion splicers and optical cables, connectors, splitters, and distribution boxes, and it is the only company in the world with a collective production system that produces everything from materials to complete products in one single factory. The FTTH total solution of UCLSwift is the best choice as we preserve the values of customers. Thank you.